take it from there. I'll give you a few minutes to do that. Okay, guys, I'm starting with number one. And remember, for number one, you can use the method that you prefer to convert 19 to binary. Sometimes if you look at the structure of the number, you can cheat a little bit, make it quicker. But again, if you're not comfortable doing any of these quick methods, just use the method you're comfortable with. Because you can never lose marks for showing too many steps, always safer. So here I spot that 19 can be written as, well, let's see, this is right. 19 is 16. Okay, maybe not. Maybe the method doesn't work here. 19 can be written as, page 19. Okay, what if we write it like this? 19 as 16 plus 2, 18, 19. If you can immediately write your number as base 2 numbers, then you kind of can do this thing a bit quicker. But again, guys, don't use these methods if you're not sure what's happening. Okay, so I write it like this, which means 16 is 2 to the power of 4. 2 is 2 to the power 1. 1 is 2 to the 0. So that can then be written as, again, this is kind of a recap of what we did before a while back. So I'll write this as 1 times 2 to the 4 plus 0 times 2 to the 3 plus 0 times 2 to the 2 plus 1 times 2 to the 1 plus 1 times 2 to the 0. Right, and the strings of 1s and 0s at the beginning here is our answer in binary. So that's another way to do the same thing. So that means 19 in binary should be given by 1, 0, 0, 1, 1. Is that it? Okay, perfect. Right. So again, if you can spot patterns or you can spot 19 to be written as some combination of base 2 powers, then you can write it using methods like this. But again, you don't have to, because the method we have already, which is just dividing by 2 and taking the remainders, that works perfectly fine. So use that if you prefer that. Okay, so 19 is just 10011. So it's say using 8 bits. Yes, it did, right? So we need to use 8 bits to represent this number. So this has how many bits? 1, 2, 3, 4, 5. 5 bits. So we need to include zeros to make it an 8. So I'll just write the number as it is, 10011. That's 5 bits, so 6, 7, 8. So that should be our answer for number 1. Let's just highlight that. That's answer for number 1. Okay, so number 2, we're using 2's complement here, so we have to do 3 steps to get number 2 right. Step 1 is to write 19 in binary, which we've done already. I'll just repeat it here. 0, 0, 0, 1, 0, 1, 1. Right, the next step is to invert all the digits, so that we can do 1, 1, 1, 0, 1, 0, 0. Did I miss something? Yeah. Oh, sorry. Let's just sort that out. There we go. Okay, thank you. Okay, all good. Thank you. So now the next step is to invert all the digits. So let's do that. 1, 1, 1, 0, 1100. And the last step is to add 1 to this. So I'm going to use the method that works all the time. Since we've only seen that once, I'm going to be careful to show you guys that method again. So add 1 to the result. I'll do it like this: 1 1 1 0 1 1 0 0 plus a binary 1. So that's all zeros here to the 1. So we add it the way we did before, the old-fashioned method. So from the top, the first one, 0 plus 1 gives us 1, 0 and 0 gives us 0, and so on. That's 1, 0, 1, 1, 1. So that at the bottom is our answer. Okay, so we're getting easy ones that are working out nicely. What did I? 2. That's just part of our 3-step method. Step 2 is always to just invert all digits. Yeah. I think okay, I got it. This one. Okay. All right, so that was number 2. Let's look at number 3. So again, guys, I'm just going to do the first step very quickly. Convert 107 into binary. So can you guys tell me what you got as an answer there? Right. So we start again, 1101.
0 1
0 1 1. Okay, perfect. So that's 1 2 3 4 5 6 7. So I'll add 1 more 0 in the front to make it 8 bits. Right. So number 3, we've done this many times, so I'm not going to go over that. Number 4, we're just going to follow the 3-step method again. So let's say step 1 is done already. That's to write our number in binary using 8 bits. So that's done. I'm just copying that from above. Step 2 is to invert all the digits. So that will be 1 0 0 1 0 1 0 0. And step 3 is to then just add 1 to this. All right. So again, I'll do that carefully using our method. So I'll take 1 0 0 1 0 1 0 0 plus a binary 1, which is 0 0 0 0 0 0 0 1. Okay, and then using our method of adding, this is quite a straightforward one as well. Okay, so that should be the answer. Perfect. Okay. Anyone else's brains are scrambled by some kind of sound? Yeah. Oh, here's the second. Okay, I can still hear that.
Yeah.
Guys, is someone playing some kind of sound? I can still hear it. It's okay. It's not here. Who was in It's getting like higher. Yeah, I think someone's phone is doing that deliberately, probably. No. I didn't accuse you.
No, it's not now.
Okay.
He was saying.
All right.
No. I swear, I keep getting fun. Oh, yeah.
Everyone just check if aliens didn't lay eggs in your ears or something while that happens. Always checking, yeah. Okay, guys, any questions for number 1 to 4? Is everyone managing to do these more or less? Okay, that's good. It's just why is a good question, yeah. So again, I'm a physics guy, not an IT guy, so I just follow the rules here. Okay.
It's not part of the first one. Oh, okay.
Okay, so the first one was just like a historical way, how they used to do it before. This is how they do it today.
No.
Yeah. Because there's like no mistake with this one. With the first method, there's some places where it goes wrong.
Okay.
With this method, it works for everything. All right. Okay, so guys, now this one here gets slightly more complicated. Converting a 2's complement number back to decimal. So this is a 4-step thing. And I think step 1 is usually where people start getting stuck. So let's see if we can work through this carefully. And maybe we can find a shortcut here. Okay, let's see. Let's try them and see what happens. Okay, let's see. How's our time? We've still got about 10 minutes, so we can just do at least one example here. So let's first read through the steps. Okay, so converting a 2's complement binary number back to decimal. So we start with some binary number. First thing we do is subtract 1 from the number. That's already where we have some trouble. Subtracting a binary 1 from a number is, you have to think a little bit about it. I think there's a method we can learn that makes it easier, which we'll look at in a moment. Maybe we'll get stuck at number 1 for today and we'll do the rest later, but let's see how it goes. Okay, step 2 is then to invert all the digits. Step 3 is to convert the resulting binary number to decimal. And step 4 is whatever number you ended up getting, you add a minus sign to it. Right, so this is assuming we're converting a negative number back to a negative decimal number. Okay, because it was positive, we don't have to even worry. It's positive, we just do it the way we used to do it, which is the division by 2 method. No, sorry, it's the other one. It's the expanded form method. All right, let's try one. Follow the steps. So convert this binary number to a decimal number. So this first one we'll do together. Let's make sure everything goes according to plan. So the number is 111,000,10. Okay, so that's where we're starting. Step 1 says subtract a binary 1 from this number. So we're subtracting 000. How many zeros here? 1, 2, 3, 4, 6, 7. So subtracting 1 from a binary number. So I'm going to show you guys, if you can intuitively do this, it's good. The answer here is going to be a number which, when you add 1 to it, you get back to this, right? That's what subtracting 1 does. So the answer is going to be a number which, when 1 is added to it, we get back to the original. Right? So that's a little bit complicated to think about. But just try and imagine what that number will look like. Let's see, it'll be 111,000,01, right? If I add 1 to that, I will get back to what we started with. So this is usually where people make mistakes. So I think what we can do is we can do it the way we did the last time, which is the old-fashioned method of adding. But now we can only add, we can't subtract using that method with binary. We can only add, right? So if I write it like this, 111,000,10, what do I have to add to subtract 1? I'll have to add -1. Right, so I can add -1. What does -1 look like in 2's complement? We have to work that out, I think. So what does -1? I'll do that here on the side. Let's see what -1 looks like in 2's complement. So what's 1 in binary? So I'll just do the 3-step thing here to work it out, right? 1 is going to be 0, 0, 0, 3, 4, 5, 6, 7, 8. Step 2 is to invert all the digits. So I'll get 1, 1, 1, 1, 1, 1, 1, 0. And the last step is to just add 1 to this, right? You guys can do that in detail in your own time, but I'm just going to give you the answer here. If you add 1, it's just going to be all 1s. So this is a 2's complement, 1 in binary. I mean -1, sorry. A 2's complement, -1. All right. Okay. So I'm just doing this to see what -1 looks like in 2's complement. So this is just side work. So this is what -1 looks like in 2's complement. Right, I was just checking that. Because now I know if I add -1 to my original number, it's the same as subtracting 1. That's why I'm doing that, because what is it? Step 1, right? Step 1 is to subtract 1 from the number. So I'm just adding -1, right? It's a bit of a weird way to do it, but in binary, we can't subtract numbers. We can only add numbers. If I want to subtract 1, I have to add -1. It works out to the same thing, right? Because there's no subtraction in binary. So let's add our -1. Let's see what happens. Let's see if it makes sense. 1, 1, 1, 1, 1, 1, 1, 1. Right. So let's do this and see what happens. So the first one, 0 plus 1 gives us 1. 1 plus 1 gives us 10. 0 carry 1, so that's another 10. That's another 10. That's another 10. Now I've used my head here for a second. So that is 10. That gives us 11. So that's 1 carry 1, another 11. 1 carry 1, another 11. I have to drop it, yeah. So we end up with an extra bit here because we're supposed to get 8 bits. So that extra bit, all we do is we just cut it off. And we start with 8 bits, so that extra bit, we just cut it off. And what's left here is our answer. So this part here is 1, 1, 1, 0, 0, 0, 0, 1, which is what we ended up with anyway. Try to use intuition to work it out. So this method works, which is a good thing to know. I'll go over it again in more detail when I see you the next time because it's a little bit confusing, a little bit of a strange thing. But anyway, that's step 1. All we did was subtract 1. And subtracting 1 became so complicated because there's no subtraction in binary. Okay, so we have enough time to finish this thing. Somehow it's always a thing where we end at half past and everyone like, but I guess for maths, we shouldn't do too much in one go.
I agree.
Yeah. So half past is good. So step 2 is to invert all the digits that we can do. Invert all the digits, we get 0, 0, 0, 1, 1, 1, 1, 0. Right? Inverting all the digits. Step 3 is convert the resulting binary number to decimal, so that we can do quite easily. Convert this number to decimal, we will get, let's see, 2 to the 0 plus 2 to the 1. Sorry, not 0. It starts at 1, right? It must start at 1. 2 to the 1 plus 2 squared plus 2 cubed plus 2 to the 4. Okay, so that is going to be 2, sorry. Okay, 2 plus 4 plus 8 plus 16, which is going to be, anyone here with a quick maths? 30. Okay, thank you. 30. 30. Yeah, that looks fine. Step 4 is then to just add a negative sign to this number. So that's negative 30. Okay, so that's the answer. So just to recap, we started with, what did we start with? So 1, 1, 1, 0, 0, 0, 1, 0. This is just a summary, gives us negative 30. That's the 2's complement version of negative 30. So this is what a computer would see, and that would recognize that it's a negative 30, sorry. Yeah, maybe this is a good place to stop. Let me just see where we're heading after this. After this stuff here, a few examples, we can do that next time. And all this stuff will confuse people now, so we'll look at that next time. Okay, guys, and we can stop here. I will see you guys next time. Yeah, stop.
Wonderful. Thank you.